Hello everybody, in this video we're going to be working on problem number 6 from the 2017 F equals MA exam, which is a competition that precedes the Physics Olympiad. Now I want to note that I have not taken physics yet, um, but I just took this for fun because I'm trying to sort of learn physics while also preparing for this test, which is in January. Uh, it's not my main priority. Math Olympiad is my main priority, but I'm also very interested in physics, and I'm taking high-level physics courses next year, and I basically just want to learn physics as fast as possible, because I know that if I were to learn it in school, it'd probably bore me. So, but long story short, I was able to solve this problem without having much knowledge of physics, because I don't know. This is something easy to understand. So we have these four masses that are all attached to strings, which are attached to cross beams, and we have this string down the middle, and we're given the masses of three. We know the masses of three of the blocks, and we want to basically find out what the mass of this third block needs to be in order for this to be in static equilibrium, which basically means it's leveled out. And so when I first saw this problem, I was thinking, oh shoot, this is probably like something weird to do with tensions, but then no, it's much simpler than that. And it all starts with the simple example if you have a seesaw. So here I have basically just a flat plank and it's on a fulcrum right here. The fulcrum divides the plank into two distances, d1 and d2, and on each side of the plank sits two masses, m1 and m2. And basically the relationship between these four quantities is that the product of the mass and its distance to the fulcrum is is equal no matter what mass you choose. Um, and sort of this has a more general notion that if you allow this to sort of be if you allow the fulcrum, right? This is the center of mass, because you're balancing, you have it's balanced, right? It's balanced at this point, so it's the center of mass. And the way you calculate center of mass is you multiply each mass times the distance to the center of mass, and you add those all up and you divide by the sum of the masses. So here, this is actually just sort of a seesaw with four things on it, right? At different distances. And we want it so that we want to find out what this mass is so that if we take the product of all these masses and their distance from the center of mass, we want to know, right, will this balance out? Will the center of mass be at this location? So a nice way, a convenient way to tackle this problem is to let the center of mass, right? This is the center of mass because everything is sort of related in distance to it. So we let this just be the origin. This is 0. And so masses 1 and 3 have a negative distance, right? So we would multiply them by the negative of their distance and then add that to the product of these masses times their distance, which is positive. And we want that to equal 0, so we just get a simple equation. So in other words, we have d1 times m1 plus d2 times m2, and so on. So if we write that out, and I'll use some space down here, so if we write that out, we get, and so, oh, and this is m2. So we have these four, basically, uh, mass times distance, and we're summing that up, and we want that to equal 0. So normally, if this were a non-zero center of mass, right, we would have to divide by the total sum of the masses. But by strategically choosing this to be 0, we don't have to divide by the sum of the masses because it doesn't matter because the sum of the masses will never be 0, right? Um, so now we can just attack this, right? This is just a linear equation, and we get it simplifies just to the mass times zero point 0.2, which was his distance, equals 140. So the mass is just 700 grams, and so that's the final answer. So thank you for watching, and if if you want more diverse content, I know I do pretty much only math, but if you like the sort of physics, probably in the next year when I learn more advanced physics, I'll probably do some topics on that. Um, and I just thought this was a cool problem. This is pretty much just math. I mean, it's like the least physicsy question in here. Uh, Hence why I solved it not knowing much physics. So anyway, just let me know if you want more physics content in the future. So thank you for watching, and I'll see you in my other videos.